right? Well, one of these things is overhead and they're playing with them, because children will do things like this in countries where firearms are lying around. So a child picks up a gun, the predator drone goes, right, enemy combatant, not friendly, it's got a gun, engage, shoots a missile at it, kills a child. Okay, so, I mean, that's probably pretty simplistic. I'm sure they'd consider it in a lot more detail than I've done in 2 minutes. But this just shows you why you can't just use just logic, I don't think, in terms of ethical dilemmas, because there's always going to be something that you haven't considered. You see what I mean? Yeah?
Could I just say quickly that
Yes, yeah.
logic is one thing, but artificial general intelligence is about learning and about program learning, about things on the fly, not just if-else statements that go along.
Yeah,
that
sure.
have been pre-programmed.
Sure.
It's about reprogramming its own.
Definitely. So yeah, so what we're saying is it's not just a static program; it can learn.
Yeah.
But one of the things that human beings, at least, seem to need in order to learn is emotional value to give value to their logical reasoning. So, again, I perhaps should have gone into a bit more detail on this. People with orbitofrontal damage sometimes have problems with decisiveness and making decisions, like what restaurant should we go to? And if they can't anticipate positive or future negative consequences of a result of that action, their logic doesn't have any value to reason with. Does that make sense? So they can still learn and infer, but if your logic doesn't have any value, like positive or negative value to reason with, then it's very difficult to make decisions, even if all your logical kind of processing is intact. And so in some way we would need to put some sort of value into these kind of things such that they could make those kind of decisions you're describing on the fly. Does that make sense?
Yeah.
If there's no value to logic, you just can't, you see what I mean? And what was your question, sorry?
Well, I see exactly what you mean about that, and I think that's probably certainly very true with humans.
Yeah.
But I can't see how that would come into play here with pure technology.
Yeah.
Because its ability to execute that algorithm is independent of the outcome. It's going to do it anyway. And if you have a whole bunch of if-else statements, but incredibly a lot of them, right, with incredibly advanced sensors, etc., and you evolve that over generations of technology, it's really going to be indistinguishable from the human making those decisions. So
I think
whether
that's
there's value
valid,
there with that positive outcome or not, I don't think affects the practical element of it.
Okay. If they're explicitly programmed if-then statements, then I agree that the majority of the time it would be completely indistinguishable, and that basically you found another solution to the problem. Different from how human beings do it, but it's another solution. As we say though, that doesn't really allow it to necessarily learn those things for itself, if you see what I mean. That's explicitly pre-programmed beforehand, isn't it, though?
If the first time it did it, you had a feedback, look, bad, you killed the child, because it was less than 5 feet, that gets programmed. I mean, how it actually comes to construct this myriad of if-else statements is in a sense not relevant here, but it has a defined set of very, very complex steps which it goes to say, look, I'm going to do this outcome or this outcome.
Yeah. So you want it to learn from feedback. Is that what you're saying?
What
the neural network.
It's just that we
learn from feedback.
These steps, so there's no real distinction. It's just to us. Well, my gut feeling was it was a child, so we didn't do it.
I mean, my own opinion is that although we feel emotions are just another form of processing as well, really, aren't they? They're feedback from our environment. That was a good thing. That was a bad thing.
Right.
Like. The reason why pain feels bad is that it's probably evolved to feel bad. Because if it evolved to feel good, we go around wounding ourselves and get cut out of the gene pool. So pain's evolved for a reason, to give us feedback such that however consciousness works, and let's just avoid that one for today, we've evolved so that things like food and sex and being warm feel good. And we've evolved that being hungry or heartbroken or cold are bad. And so although it's emotional value, it is actually just feedback from the environment processing as well. So what I'm saying is we'd have to solve that problem. I'm not saying there's anything about emotions that is anything extra or spiritual. Like I'm saying that in some way that programming would have to be done. It might be able to be done the way you're suggesting, but it needs feedback from the environment. And I get onto that a little bit with the brain simulation. Yeah?
Okay, I'm going to go out on a bit of a limb here.
Okay, if it's a lot of a limb, I might save it to the end, but
I'll try and keep it easy. Okay, we're assuming that the human race is one united mass and we've all got shared interests.
Oh, right, yeah.
But the pleasure that we each take in something, for example, and this is in no way judgmental, wearing clothes made in a sweatshop, eating meat, wearing leather, is much less than the pain that it costs the person or animal.
So that's an empathy deficit on our part,
so
isn't
there's
it?
an empathy deficit.
Yeah.
So who are we to kind of say that when we create these machines that are conscious and sentient, that they're actually even going to care if they can get the choice?
Well, that's basically the whole point of this talk, isn't it?
But we don't. So how are we going to say that we don't care? So how are we going to create those that care? So yeah, I get that.
Yeah, totally. What we're saying is that we want to make machines that are like nice, empathic humans that care about one another's feelings.
But can we make them in our image?
We don't want to make machines that are in the image of human psychopaths that are reasonably present in the population.
We're not psychopaths, but we have all cost some other being.
Oh yeah, sure. I mean, I think that the thing with empathy is that I think there's actually probably an optimal level of empathy that helps you to reproduce. I think that if you're incredibly selfish, everybody in your tribe hates you and you're kicked out of the tribe and you starve to death. Whereas I think if you're hyper-empathic, no offence to people like David Pearce that are concerned with the well-being of all beings, your average Buddhist monk probably has less kids than someone that isn't so bothered about the well-being of all beings, if that makes sense. So there's probably an optimum level of compassion that helps you to have the most children.
So you're saying that we're not going to model them on us?
No, I think it'd be better if we modelled them on the most compassionate and decent human beings in our society, personally. And that's a value judgment by me as well. Like, you wouldn't want these things to be too compassionate. You know, your learning algorithm might be like, if you're going to get 10 enemy combatants, it's okay to kill one civilian.
You probably want a follower, not a leader.
Yeah.
Her question, rather than yours, introduced something that I've raised before, which is really the individual organism, whether it's a dog that feels like you said, or a human being, is actually motivated by something beyond themselves.
Yeah.
Now, another thing that you'd have to program into said AGI is actually that kind of motivation, not just the motivation.
What do you mean by motivation beyond themselves? Do you mean feedback from the environment?
The species propagating. You've talked
about
evolution.
Yeah.
I mean, where does that come from? The personal or group teleology.
In evolutionary terms, I guess, like people that basically get a greater dopamine hit from sexual activity are going to probably reproduce more than people that aren't bothered by it. So AGI, it's evolved along with everything else.
A single one has no purpose in that.
So it hasn't got pre-programmed by evolution purpose to exist.
So that has to be
made up as well.
And whether you can program that into one.
Well, this is one of the tricky things. We'd have to effectively program some sort of reinforcement learning, which is actually one of the things I'm going to come on to. Yeah, go on quickly.
I was going to say very quickly, the problem there is, isn't it the zeroth law of Asimov's zeroth law was protecting humanity? And the problem is if you're talking about humanity plus to begin with, that rather...
what counts as human?
Straight off,
Yeah, I mean, like the AGI might not count a human psychopath as being human. It go, well, I've been programmed to be this because this is considered human. Okay, they're not human, I can kill them. And bizarrely might act like a psychopath towards a psychopath, but not act like a psychopath towards others. I mean, what basically I got down to is, might we have to model in some way artificial emotions as well as artificial intelligence? That's not necessarily to mean emotions in a conscious way. It could be in a purely algorithmic way. Artificial intelligence people talk about reinforcement learning. In psychology, we'd call it operant conditioning. So the dog learns to sit because it gets a reward, because the reward has value. Without the value of the reward, the dog wouldn't learn the task. So that basically what you need is valued feedback from the environment, which in humans is what we experience as our emotions. But in the AGI, it could be something different. So some AI researchers recognise this. Omohundre talks about that you need drives, like goal states and aversive states, where drives alone would produce sociopathic behaviour. And you need some additional drives as well. And I haven't got even time to show a minute of this video, but there's an hour-long lecture there. I'll put this up online, so if people want to look at what the AI people are thinking about to try and deal with some of these problems, you'll see. So that was the AGI. Just talk very quickly about brain simulation, then we'll just go to a general discussion. I mentioned about reinforcement learning, which is an AI term, which is what we call operant conditioning. I'll just give you one example of that. and then I'm just going to talk about the Blue Brain Project and modelling the human brain, which is about 5 minutes on each of that, I think. Okay, so Randall Kohner, who's another person that's involved in H+ kind of groups based in America, is a computational neuroscientist who's done neural network modelling of the orbitofrontal cortex. But he hasn't done the bit that I'm more interested in, which is the anticipation of negative consequences. He's done neural network modelling of the orbitofrontal cortex to anticipate future positive consequences, which allows reinforcement learning of decisions. Basically what they did, the actual animal model of this is that you've got a monkey, pop some electrodes in front of the orbitofrontal cortex to see when these neurons are firing, and then had a button which you needed to press. And if it pressed it only when it gets certain stimuli on a screen in front of it, it gets a squirt of tasty juice, and it's like, nom, that's nice. So that's its reward from the environment. And then by measuring the activity of the neurons that are spiking in the orbitofrontal cortex, they got some idea of when these were spiking relative to the movements that it was doing. And I've got to say, I really do not understand how any of that works, because I'm not a neuroscientist. I get what it does in psychological terms, but at the neuron level, I'm not the right person to ask. Anyway, what Randall did with colleagues was to basically make a neural network and to try and get the neurons to fire in basically the same way, the simulated neurons I should say, in his neural network, to try and produce the same behaviour. And there's a talk here, this hyperlink will actually take you to it. It's probably better to watch it for yourselves if you're really interested. And basically he got similar results to what they got in the actual animal experiments. So that's some evidence that people are doing neural network modelling paired with a reward. Quite how they got the reward to work, I don't know, because I don't think he's claiming it's conscious. He certainly didn't squirt juice into a robotic mouth. It must have been a reward signal, which is, I guess, what all of this stuff gets turned into when it gets into a brain. And the neural network actually seemed to respond similarly to how the orbitofrontal cortex in the monkey responded, and that's really good science. But as I say, this is not my area, this is neuroscience, and I do not properly understand it, if I'm honest with you. But have a look at the talk online, that's a really good one.
Where is...
Yeah?
All this is available online, is this slideshow?
Yeah, this slideshow I'll host on my website, and I'll post on... Now, people come here from 2 different things. There's a Facebook group, there's also, is it London Futurists?
And there's a mailing list.
Okay, well what I'll do is I'll send a link to you, and can you put that up so people can get this, and then they can get the links and the references and look through it and steal my robot pictures, which I got from Google anyway. Okay, so that's that one. That's just to show you that there are people out there who are actually trying to model from the bottom up how these things work. Neuropsychology is a very top-down approach. We take the human brain, people have had unfortunate accidents, and we work out from what they can't do a bit more about how the human brain works. These people are from in the other direction, they're building it from the bottom up. And I don't understand how that works, because it's just not my subject, I haven't studied it. Okay, so the next one then, which is the best one of these, is the Blue Brain Project. Are people here familiar with the Blue Brain Project? Yeah? Okay, so there's a link here to the TED Talk by Henry Markham, who's the director of the Blue Brain Project. And I really urge you to all watch this from the link that I give here, or you can just use Google it and find it. Basically, what they've done is one of the most sophisticated neural network models of neurons that's ever been made. People have done larger models, but they've used much more simple neurons, whereas the neurons that these guys are modelling are supposed to be biologically accurate down to the level of the cell, although like not down to a chemical level, I don't think. But they've literally got all the receptors, all the dendrites, the synapses, everything. It's an absolutely brilliant model. And what they did is they made a model of these neurons in a rat neocortical column, which represents 2 millimeters worth of brain tissue. So this is 2 millimeters worth of brain tissue. Give you an example of complexity. And their model has 10 to the power 5, which is 100,000 neurons, and 10 to the power 8, which is 100 million connections between them. So 100 million connections in 2 millimeters of rat brain tissue. Okay? So that's just to give you an idea of the complexity. And Henry Markham, who talks about this in his TED Talk, which you should really see because it's brilliant science, claims that we might be able to model the human brain in 10 years. Right? Now, the reason for this is that computers are getting faster all the time, doubling in processing speed every 18 months. So I looked at this and went, wow, and then thought, hang on a minute, And the physicist side of me thought, I'm going to quantify that projection. I actually want to see if that makes sense. Okay? So using this as a start point, we can extrapolate using Moore's